Hi, so it's been a little while between videos, but I'm back here. I'm going to start a series on Starlink. So for those who don't recognise, this is a Starlink travel case. Inside is a version 2 square dishy. Now, I've made, prior to this, a Starlink box. So this replaces a Starlink router, uses a 12 volt conversion, custom router, and that kind of thing. So I'll post some pictures of that here, and I'll do a detailed video of what this looks like in the future. But what I want to do today is, you will have seen all these videos of people modifying their Starlinks to make them a flush mount. So at the moment, Starlink sits on a tripod, and you can move more a pole mount, and you can move it around. This is what kind of a standard Starlink setup looks like. Now that's cool, right? That's not a problem. The challenge is in the future I want to mount this on top of a vehicle, like a motorhome for travel, and I'm not averse to getting up on the roof of the motorhome every day and putting this in. I don't want to put it on the ground from both a performance and a security perspective. So what you see often online is a heap of people do it. They take a Dremel to their Starlink and they cut this bit out, remove the post, and there's some motors in here which steers the dish, and they mount it flush into generally a homemade box. I don't want to do that because I want to retain this functionality as well. So I want to have the option of having it flush mount, but also having this functionality. So my idea is this. So I've measured the dimensions of the dish. I've also measured the throw of this mount pole here, because it does move. And I reckon I can cut a hole out the roof of this, mount the dishy flush, and let this mounting post swing or move freely inside this box, and still actually use some of the other box for storage. But I actually reckon I can do that, and then when I want to, open the lid of the box, take the dishy out, and still use it like this. So that's the theory behind today's undertaking. So I have the box. I have a trusty jigsaw. I have some 24 teeth per inch jigsaw blades, which are ideal for cutting plastic. And I have a sheet here of clear, well, it says it's PVC, but it'll be fine. It's a perspex plastic screen, but it's clear with a protective film on it. So my plan is to cut a hole in the roof of the box, in the top of the box, mount the dishy flush, cut out a piece of clear perspex, stick that to the top, bond that to the top, and then seal it all up, and hope that it works with an intact dishy. That's the theory. So the roof of this, the lid of this box is actually double skinned. They are insulated, so there's a skin, an upper skin, and an inner skin, and I think they feel like they're about 20 millimeters or 15 millimeters apart. So my first idea is to measure not the full size of the dishy, but just a slightly smaller rectangle, mask it out with some tape, and cut it out, and then see what happens. So we've masked it out. It's a little bit tricky because the top of the box, the top of the Pelican case has these ridges on it. So I kind of have to work around the ridges. So I'll cut the inside section of the tape out, test fit, measure again, and then I can just take a little bit off, all the way back to these ridges. Middle ridges, they're gone. But I can take a little bit off back to these ridges if I want to. I'm going to pop it on the ground. I'm going to deploy my jigsaw blade. Now, there's a number of ways to cut this. You can cut it with a hot knife. You can cut it with a Dremel. You can cut it with a handsaw. I think a jigsaw just on a really slow speed is going to be the best option for me. Always load your jigsaw, no battery. Let me get my battery. So let's be super clear. I am rubbish at measuring and cutting things. So I expect this to be an unmitigated disaster, but I've measured like 10 times. I've mastered it out. See how we go. So at least I'm safe from like the neck up. I should probably make a hole to start with. Okay, plan B, or take two. This is also like a $250 box, so I'm a little bit apprehensive about completely destroying it. Looks great. Here's a solution I prepared earlier. Okay. You know when I said I was a terrible cutter? It's coming true. Okay, so I've cut a line. It's as crooked as anything. Yeah, I think it's okay. Time to turn a corner. Would I choose to cut it with a jigsaw if I did it again next time? Maybe not. But I have a sneaking suspicion that we're in. Okay. So I'm just going to tidy up the edges and then we'll have a test fit. I might get the vacuum cleaner out as well. So my original plan was to have a small inner hole, lower hole, and a larger outer or upper hole, and it would drop the Starlink in and it would sit between the two layers of the box. Excuse me. So I actually now looking at it, where I had that initial guess of 15 to 20 mils, I think it's going to be perfect. So let's do a test fit. So the aim is that this is too big. Perfect. I love it. Okay. Let's trace the outline and go again. So I've traced around the edge of the Starlink and I've got a really nice outline. Now I can't use the jigsaw for this next hole because the blade of the jigsaw is too long, and I want to keep the inner skin at the same level that it is now. So I'm going to use a Dremel, and I've got some heavy duty cut-off wheels, and I'm going to run it nice and slow. Now I'm just going to go literally around the whole circumference just with the Dremel and cut it out and just open up this larger hole. Now I do want to overcut this larger hole So I've got this kind of U-channel, U-channel rubber sealant. And my aim, my kind of thought process is that I'm going to line the cut with this rubber sealant all the way around. Not for sealing, just for aesthetics, really. Just so you can't see my dodgy cuts. So that's kind of my aim. So I'll overcut by probably a couple of mils just to allow for this rubber and for the Starlink to fall through into the hole, into the gap below. Now, the next challenge is how I get the Starlink out once it's in. I think it's a problem for later. First blade down, like I got the packet. Okay, moment of truth, take two. Now, I don't expect this to fit. Well, I'm completely wrong, and it fits bloody perfectly. Okay, let's keep going. Okay, so I've cleaned it up. It's actually looking remarkably good. Now I'm just going to tidy up some of these with some side cutters. I reckon they're good to start lining it with the rubber. So I'm going to do the inside. Run first. Oh, the light is bad. That's what you get for doing this inside the garage with the door closed. So I'm going to do the inside lower bit first, and then just kind of go around and see how we go. Time for another test fit. I'm less optimistic about this one, but we'll see. Yep, it's a little bit, the rubber, I didn't overcut. I needed to overcut maybe a little bit more. Looks pretty good inside though, doesn't it? I think it's just the corners. Let me cut out the corners a bit more. Cut after you test. So now I've got a 10mm gap here in my seal, but that's okay. Let's test again. Oh, it's tight. I can make it go in, but I won't be getting it out again. How much do I care about it coming back out and onto the stand. Okay, let's open this up a bit more and see how we go. So it's interesting because I started off with no gap, then I had a 10mm gap, now I've got a 20mm gap. 18th time's a charm. Don't know about you, but I reckon that is pretty good. I reckon that's awesome. Now the theory goes, right? Cut this to size. Alright, well, I don't know about you, but I reckon that's pretty good. Alright, I'm gonna go and get some, I might get some baby wipes. Have you heard the good news about baby wipes? I'm gonna get some baby wipes. Clean the whole thing up. Fix the rubber seal here. Glue the rubber seal on. And then take it from there. So I had a terrible thought. But it's one that we're testing now. I need to have this stroke angle be sufficient that when it's closed, this leg can move and it won't hit the bottom of the box. So I've powered it up and I'm not sure what it's doing. But I'm going to unplug it now because the leg is fully extended. So while the leg's fully extended, I'm going to kill the power and then we'll have a look inside. Okay, so I know that I can see that it fouls the side of the box. It's going to be close. I might chuck you inside and see what happens. What's the verdict? So I've cleaned it all up. I've cleaned up the rubber as well. I've got Locks and Loctite 424. If you go and search online, you can find like a poster which details every Loctite formulation there is and what it's really good for. So this is a rubber, difficult to bond rubber. So it's really around, you use it on tires and things like that, but perfect for rubber to plastic bonding. So I'm going to try this. I've also got some clips to kind of keep it in place as we go. So I've measured, and it's time to cut the perspex. Normally you would cut it with a jigsaw, but my experience with that hasn't been really good. So I'm wondering if I try and cut it some other way. Let's measure it up and see how I go. So, I'm an idiot and I don't learn from my mistakes. I'm going to try and jigsaw it. Found my first problem. I've had a genius idea. Don't go anywhere. A guide. So simple, so easy. Why didn't I do this last time? Because it doesn't work. I hate jigsaws. Jigsaws are ridiculous. When in doubt, go back to Old Faithful. Probably the correct tool is a little. You can get tiny little circular saws, craft circular saws, with like an abrasive blade, like this type of blade. That's probably the right tool for this. My dad does have one, but that would involve driving to his house and getting it. I'll just do this. What do you reckon? So I reckon this glue is pretty much on its way to being set. So I'm just going to take the top, just for a hot minute, I'm just going to take the top clips off so I can test fit this. Tell you what, friends, that looks pretty good. So the question now goes, so I'll round off the edges. And the question now goes, no, can't get a good seal. So there's a couple of options. I could actually glue it down, which was my original plan. But what I'd have to do if I was going to glue it down was take out one of the edges inside, so I can get the Starlink in and out from inside. I don't really want to do that. So probably what I will do is go and get some. So I've got like this rubber edging, which is now covered in white. It's a problem with plastic, it's everywhere. So what I'll probably do is go and get some foam. So again, some rubber foam, which I'll stick around here, maybe even on top or just slightly over the edging. Oh, box got a bit damaged there. So I'll glue that over the edging, or stick that over the edging, and it's just an expansion foam, which I might actually have. Stand down. I have some expansion foam, which is just some expansion rubber, which will allow me to I'll just put a bead around it, and it will allow me to get much more compressive force with the perspex. All right, well, let's try it. That was actually remarkably good. I'm really surprised. It's this little kind of single, so you can see it just compresses. It's self-adhesive, it's sticky as anything. And it's got like 3-4 mils of, if not more, probably more of travel. And it just stuck on beautifully. The radiuses were excellent. It's got a reasonable, I'll fill this with some silicone, it's got a reasonable kind of mating. I've done it opposite the mating. I've bonded my clips. Okay, where'd that perspex go? Oh, that's excellent. So I'm going to have to clip it here. I have to clip it in each corner, but also midway along the span as well, because it is quite flexible. I don't think, even if I put a rigid brace along, I don't think it'll be enough. So I think I need to put a bolt, like a mechanical bolt through here, and then a mechanical bolt through in each corner. And then I need to do something here where I do a clip or a mechanical bolt through as well. I bought some just steel angle from I just bought some steel angle pieces while I was at the hardware. If I drill through here, I've got some little ones, so I've got some big ones, little ones. If I drilled through here to lock that in, then I'd need to seal that screw as well. You know what would be ideal almost is just like a bolt through here. Okay, we're back. It's the next day. So I've been thinking about it a lot, and I've been looking at what our options are for securing this. I'm not super optimistic about the solution, about having this compressed down, just because I think water will leach underneath it, and especially if this is going on a vehicle's roof and there's not just down kind of water coming down from rain, but there's also water being forced in through the force of driving through rain, essentially, or driving through high humidity. So I'm not convinced that a compression kind of approach is going to be the best. However, yeah, the best would be to bond it using, something like the best idea would be to bond it using something like this Sikaflex 291 or a similar Sikaflex product, an adhesive sealant, and bond the thing the whole way around, and bond the perspex to the top of the box. The other challenge is we've actually seen some flex, because we've cut a hole in the box, which is entirely predictable. We're seeing some flex in the box here because we've compromised the structural integrity of it. So the better way would be to bond it down. The challenge is I do want to be able to remove the Starlink Dishy. And so I think for that reason, if I did want to bond it down, I'd have to open up this kind of opening in here a bit, so I could remove the Dishy from inside. But I don't think the physics of that work. I don't think there's enough space, there's enough width in the lid for me to set it in. And if I extended this opening, this incision down a long ways and tried to slide it in, again, I don't think the angles would work. So in the absence of any other option, I'm going to do a compression solution. But what I did discover, now I've lost my piece of plastic, here we go. What I did discover is that because of the flex in the box, I do need to have a compression point or pinch point midway along this span. And so I was going to do a screw in each corner or bolt in each corner with the wing nut, wing nut. I was going to do a bolt in each corner with a wing nut and then a mid-span compression. But what I actually noticed is I have an issue halfway along this span as well. So what I'm going to do is actually, rather than the corners, is two points along this mid-span here, 2 points along this mid-span here, and a point in each mid-span here. And I think from just my kind of rudimentary testing, I think that's going to be the go. I think we're close to done. So there's, the bolts are all in. They're looking good. We'll get some fitted washers. So I've sealed up all the bolts. I mean, there's no problem you can't sell with a healthy dose of sealant, I presume. Well, that's my strategy anyway. And I'm going to try and tighten it down. Now, I might replace these with nylock nuts, but, excuse me, my thought process is I shouldn't need to, because obviously there's pressure. Oh, I'm not quite getting the tension there that I wanted. Yeah, tension on this. Maybe I'll move to a non-oversized washer. Give me the tension there that I want. Yeah, no, there's not enough tension in the corners because it will lift up. See, that's lifting up. This thing's going to be the death of me, isn't it? It's all well and good until you start drilling holes. I don't know. I'm on the fence. I think it's just maybe these corners. That corner's not sealing either. Oh, no, yes it is. Oh, it's not as much as I'd like though. Plan F. So I think where we left off was that I wasn't happy with the corners and the current fixture method that I had kind of engineered. So I have done some research. My next idea was to get some riv nuts, which is like a nut, a captive nut that you can rivet or compress through the plastic, and then you can screw a bolt down into it. That's a pretty good idea, but the challenge I had is most of them have an open end, so essentially you're just relying on the thread of the screw or the bolt to seal it, and that wasn't going to kind of do what I wanted. So then I found these, which is like a rubber captive nut, and it's used for putting in windscreens in vehicles and windows into things. So it's generally designed for flush mounting, so you drill a hole through, push this through, make sure it's flush, and then tighten a screw down with another material flush to it, and it will pull the rubber up and expand and seal. It does have an open end, but I think it will still do a lot of what I want it to do. So I'm actually super confident about this. The challenge is we don't have flush rounds, as you can see. So what I've done some testing on the bit that I cut out of the middle here. And if I drill an undersized hole, so these require about an 8mm hole normally to put them through and then compress up. So if I drill a 6.5mm hole, which is what I've been drilling here, I can force them through from the back, and that way they don't come out. And as I screw the screw, it actually does expand and compress and provide the seal that I want to provide. So I'm going to do that. So I've made some good progress. I've got all of the fasteners in the lid of the box, and I've found a way to secure the stand of the Starlink in the box as well, just using a strap, essentially an elastic strap. Now what I'm looking for is to build a divider in the middle of the box to separate the half of the box where the leg of the Starlink may swing, and separate that from the other half of the box where I'm going to use it to store some Starlink cables and ancillary stuff. So just to maximize the use of that space. So I haven't learnt from my experience. I'm going to use the perspex, and I'm going to cut it with a jigsaw. I'm nervous, but I'm not worried because it's internal. If it looks terrible, I'm happy with that at this point because I'm getting towards the end of the project. Let's say that. Okay, let's cut. So here we are, we've got, I've got perspex shavings all over me. So we've got like 95% of the box complete. So here's what we've got so far. So this is the Starlink base here. And this is kind of the only way that I could position it, upside down and jammed up, which would allow the leg of the Starlink to sit here and still swing, and also allow me to open here and not have it foul, because most of the issue was here when it would foul it as I was opening up. I've got this perspex divider, so I can use this side of the box for storage of cables and whatnot. This side will now be clear for the leg of the Starlink. I'm going to just now what's next. So I'm going to put a network port through here. So this is a weatherproof locking network port, so it allows me to keep the Starlink cabled inside the box, but be able to connect and disconnect a cable outside the box. So let's do this. Okay, moment of truth. Custom power supply, power injector, router, blah, 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 blah. Box. Custom cable, well, not custom cable, Dishy cable with the end cut off, and it terminated into an RJ45 with a very particular pin out to support my power injector. Cable. Okay, and we have power. So it's spun around, which it does. And the cable is good, the cable's not fouled or anything like that. So I actually don't know if it's going to try and tilt. It might, but it has no GPS, so maybe I should try and stow it. So I've come outside to test it. I've got my custom router power supply, I've got Dishy, and now I'm just waiting for everything to boot up, and we'll kind of see how we go, I suppose. Right, let's give it 10 minutes. Okay, so I moved the Starlink off the grass and just put it on the roof of my car here. And so you can see it's on the roof of the car. There's my power supply and router. Bit of a shadowed position, but listen, within 10 minutes it had booted up. It hasn't really moved, so the staff hasn't really moved. So my presumption is that it has a level, like a G meter or an accelerometer in the ditch, which would make sense, right? And so it senses that it's horizontal, so it actually doesn't swing at all or move at all. It does a bit of a twist and stuff, but it's working. So let's just presume that it's good. I'll post some, I'll show some screenshots of the speed test here, which is literally, I took it just before I started recording this video, so it's moving now. Let's have a look. So it's super interesting. So I tried to do a movement, tried to move itself around. Pretty much immediately in the app, I got a warning saying my motors have stuck, which I'll post a screenshot of here somewhere. So from everything I read online, it doesn't matter, like you can just leave it like that and it just keeps working. And still, so what I actually did just to test that is I did a speed test after it had done a bit of movement. I actually got double the speeds which I got in the previous, which I'll also show you right here. So I'm actually fine with it. I'm pretty happy with it. I'll do some more research about if I actually had disconnected the motors, would I still get that motors stuck warning? But I don't think it's a huge issue. But all in all, I reckon it's awesome. So I'll do some final touches. I'll show you that, and then we'll call it. So I'm in the car, as you can see, and the Starlink is on the roof, and I'll show you a picture of that here. And I've got a cable running inside to my router in the back, which is also 12-volt powered, so it's running off the car. And now the Starlink is booting, and my test is, will it work mobile? I know some people have done it, but I want to see it working for myself. It's also raining, so I'm testing the waterproofness of the box, which is awesome. Okay, let's let it boot and connect, and then we'll go for a drive. So I'm now driving down my street, 155 down, and I'll post I'm screen recording the speed test, so I'll test here, and 10 up, and I'm doing, 40 kilometers an hour down my street. So I'm just going to go up a couple of blocks away and do another run and do another speed test, but it's like not even a question of wanting to work. Yep, so I've just turned a corner again now, 120 megs down, 125 megs down, 130 megs down. 140 megs down. Not even a question. And now 21 megs up, and I'm doing 41 kilometers an hour. Just 23 up, yep. Just not even a question of not working. All right, let's do some more driving. So this is interesting. I've turned, now I'm driving due south along the coastline. It dropped to 4 down and 11 up. So that was super interesting. When I turned from west facing to south facing, the speed just kind of dropped off the bottom. But now I've restarted the speed test, 150, 160, 120, 130. So it's like seriously usable. Okay. Yeah, and 12. Okay. So just sometimes maybe when you change direction, any sustained transfers, when you change orientation, any sustained transfers might have an issue. But no, it's just spectacular. Okay, I'm going to pull over up here. Big ping time. So I've seen double ping times. So normally at stationary I see ping times 50, 60, 70 milliseconds, and here I'm seeing ping times of 100, 120 milliseconds. I mean, seriously, we're not going to be, you know, for those of you SSHing over these things while we're moving, maybe. But that's still better than, or as good as cellular in some of these fringe areas. So let's not split hairs. All right, I'm just going to pull over up here, and I'm going to start a ping test, and I'm going to drive back home with an active ping test and just see how it goes handling packets, and see if it drops any packets while we drive. Cool. Funnily enough, as I just pulled over, I'm facing well, kind of northwesterly out to sea, and yeah, 200 down. Just parked on the side of the road with the thing on the roof. You can see the kind of strap that's holding it down. All right, let's do some pings. Okay, I'm pinging. I'm parked here on the side of the road, pinging Cloudflare, 50 milliseconds, 60 milliseconds, a couple of high 180s. But let's drive home and see how it sustains its ping rates. I mean, this perfectly makes sense, right? It's a satellite, it's flying through the sky at, you know, thousands of kilometers an hour, faster. You know what's actually really interesting also is we're seriously overcast today. You can probably see out the window, super overcast. So there's no reason it shouldn't work while it's moving. We know Starlink has mobile options, so they've got dishes that support and are designed for mobile operation. And there's always this kind of conjecture that there's a software or a system or a network or a limitation that's imposed, an artificial limitation that's imposed. And on residential, or I've got an RV plan, but on these plans for preventing them from being used mobile, but I can't see it, and I'm happy to report back on how it's working. But I'm just looking at the ping times. Every 20th ping it pops up over 100, otherwise it's sitting in solid 50, 60 milliseconds, and I can't see because the writing's a bit small and I am driving a car safely. I can't see that there's any drop packets. The sequences all look absolutely spot on. So I am screen recording, so again I'll have this up whilst I'm driving. It just looks spectacular, so I'm going to call it a success. Thanks for watching. It has been a bit of a long video, but pretty involved. I will post a video soon detailing the router, the Pelican case you see with the router and the power supply and that kind of thing. So I will detail that in a future video. Otherwise, yeah, we're about to kick off on our big adventure. You've seen some hints of that on the channel. So thanks, I'll see you around. Cheers.